Good morning. Students of Technology College of Engineering from the Department of Mechatronics Engineering. I am Haris Azmi. I will deliver a lecture on unit fit and tolerances. Okay. So what are the tolerances? Tolerances are allowable sizes given to any job or product. To satisfy the ever-increasing demand of accuracy, parts have to be produced with the least dimensional variation. It is essential for the manufacturer to have an in-depth knowledge of the tolerances to manufacture parts economically, adhere to quality and reliability. To achieve an increased compatibility between the mating parts, we are utilizing the use of tolerances. Tolerances are the allowable size limit of any product or services so that they can be compatible with the increasing needs. The algorithm between the upper and lower acceptable dimensions are nothing but the tolerances. It is an absolute value. The basic purpose of providing tolerances is to permit dimensional variations in the manufacture of the components adhering to the performance criteria. The tolerances are given to the product so that they can have a functionality without affecting any features. These are the allowable limits which has two sizes. First one is the upper limit and second one is the lower limit. Upper limit will indicate the maximum size limit of the shaft or any hole that can be produced to the mating part, while the lower limit will delivers or indicates the minimum acceptable limit that can be reached by the product so that it will have a well-known functionality. Then classification of the tolerances. The tolerances are classified as unilateral tolerance, bilateral tolerance, compound tolerance, geometric tolerance. First, we will see about the unilateral tolerances. Okay. So, as shown in figure, we have a basic size. So, what is meant by the basic size? Basic size is the dimension of the actual product that can be produced. As we can say that this size of the hole or shaft should be of 40 mm size. It should be capable of doing 40 mm with the mating part. We are giving tolerances on this 40 mm size. Actually, we can't produce by any machining process 40 mm dimension, as well as if we are capable of producing that 40 mm, we cannot measure it by using any measuring instrument. Some allowable features are there or some errors are there, by that we can't measure or produce a 40 mm size. Is the natural phenomena. In order to have that problem to be solved in manufacturing processes, we are utilizing tolerance concept. Okay. When the tolerance is distribution is only on the one side of the basic size, either positive or negative, but not the both, then that tolerance is called as unilateral. Uni means one. Okay, so the tolerance is given on only one side. As shown in figure, we can see that here the basic size is 40 mm indicated by this line. So figure A is will show the unilateral tolerance, where this figure indicates that the tolerance is on the negative side, and this figure shows that the tolerance is on the positive side. So we can say that it has a tolerance limit of minus 0.02. This has a tolerance limit of plus 0.02. Okay, this figure shows the bilateral tolerance. Then where the unilateral tolerances are utilized, where the products are to be made with the other element, at that time unilateral tolerances are kept. Unilateral tolerances are always on the shaft so that it can be met with the mating hole dimension. Okay. Below zero line examples are there. Here the upper limit will show the maximum size of the shaft that can be produced, while the lower limit will show that the minimum size that can be produced by the shaft. Okay, and this one is the tolerance zone. The tolerance zone will have on one side only, for example, 50 plus 0.00 and minus 0.06 mm. So its maximum size will be 50 mm, while its minimum size will be 50 minus 0.06, that is 40.96 mm. 94 mm. Second case is the tolerance zone above the zero line is 50 minus 0.0.70 and minus 0.110. Above zero line, that is positive tolerances. These are the examples of positive tolerance where 50 plus 0.04 and minus 0.00. So it will have a maximum size as 0.04 and minimum size as 0.00. Second case, we are giving the tolerances on positive side with a value of plus 0.07 and plus 0.03. So it has the maximum size of 50.07 and minimum size of 50.03. These are the examples of unilateral tolerance. What is the bilateral tolerance? If the tolerance is given on the both side or either side of the basic size, then that tolerance system is known as bilateral tolerance system. Here you can see by this figure that this zero line will indicate the basic size of the shaft. You can see by this example, that is 50 will indicate the basic size and this line 0 will indicate the 50 mm size. Our tolerance zone is lies on the both side of either side of this 0 line. For this example, we will take 50 minus 0.04 and plus 0.02. So it will have a maximum size of 50 plus 0.02 and minimum size of 49.96 mm. Okay, so our tolerance zone will lie on the either side. So this is the example of bilateral tolerance. Similarly, 0 plus 0.02 and minus 0.02 is the example of bilateral tolerance. It is not necessary that zero line will divide the tolerance zone equally on the both sides in the bilateral tolerance system. The tolerance zone will be in any manner as per the requirement of the manufacturer. It may be equal or unequal. Next one is the compound tolerance. In compound tolerance system, the tolerance for dimension R is determined by the combined effect of tolerance on 40 mm, dimension on 60 degree and on the 20 mm dimension. Here in compound tolerances, this will have a tolerance zone of 0.04 and this will have a tolerance zone of 0.01, 0.02. So as per that, this R will have a dimension with a tolerance zone affecting by these two dimensions. This tolerance system is known as compound tolerance. What is meant by geometric tolerance?